ExpressRoute is one of the most important networking technologies in Microsoft Azure. However, it can be difficult to test since you need access to either network provider or your own physical networking equipment in the locations where ExpressRoute is offered by Microsoft. I am Jose Moreno, and I have recorded this series of videos to help you understand better the provisioning process of ExpressRoute end-to-end. And I will give you also some tips and tricks that might be helpful when troubleshooting ExpressRoute when things are not working as they should. We will be using this environment that I created for the purpose of this video. It's composed of hub and spoke network design in Azure, one of the most common deployment options, where you can see a virtual network for the hub and another virtual network for the spoke and virtual machines in each. You can see the setup here in Azure. Essentially nothing spectacular: virtual networks, virtual machines, virtual network gateways. For the on-premises part, we will use services from our Megaport partner. We created a Megaport cloud router already connected to Google Cloud. Google Cloud will be used to simulate the on-premises environment. Google Cloud has an autonomous system number of 16,550, that's fixed. And you can see here that our Megaport cloud router is getting the route from Google Cloud because it's already connected to it, and the autonomous system path is 16550, as it should be. There are different properties that you can configure in the Megaport cloud router. One of the most important ones is the BGP configuration. I configured this Megaport cloud router with the autonomous system number of 65,000. This is important because we will see this number popping up in the routes later. Something which is very important to understand is that ExpressRoute locations are different than Azure regions. As you can see in the diagram, there's an Azure region on the top where the hub and spoke environment is deployed, where the virtual machines are. These virtual machines are ideally spread over availability zones. However, the ExpressRoute locations in the middle, where our Megaport cloud router is deployed, is outside of the Azure data centers. This is actually at the edge of Microsoft's backbone network. This is a very important remark, and I would strongly recommend you to build your diagrams following the same topology. You have on one side Azure with the virtual network gateways. On the other side, you have ExpressRoute locations where your ExpressRoute circuits will be deployed, and those will be connected to your on-premises sites. Continuing describing the ExpressRoute location, in the next part of the video, we are going to deploy this ExpressRoute infrastructure. All right, so let's create our ExpressRoute circuit. The first thing, of course, is defining a resource group, and the second one is choosing the resiliency model. There are 3 resiliency models, as you can see. Essentially, whether you deploy 2 lines in one ExpressRoute location and 2 lines in another one, or 1 line in one and 1 line in another one, or you just deploy both lines in a single ExpressRoute location. The middle one, where you deploy 1 line in one ExpressRoute location and the other one in another ExpressRoute location in the same city, for example, in this case, it would be Frankfurt and Frankfurt 2, is what we called Metro. It's not available on all locations. So if you happen to choose one location where it's not available, or there's not capacity in that particular region for that particular partner, then it's not going to work. So we are going to choose Metro. We're going to choose the slower speed. By the way, you notice that by choosing 50 megs, then you cannot choose anymore the local SKU, which is the cheapest one that only allows you to connect to one region. Standard is going to let you connect that circuit to all of the regions in one political or geopolitical zone, such as Europe or Americas or Asia. And then you have the billing model. Essentially, either you pay for the bandwidth or you get an all-you-can-eat billing. So in monitoring, this is relatively new. You might not have seen this. Essentially, Microsoft is recommending you which alerts should you configure. so that when certain metrics go beyond or below certain thresholds, then you get notified about it. Pretty convenient feature, because otherwise customers were flying blind and were not sure about which alerts to configure or not to configure. We're going to pick up the recommendations, then you hit on next, and in the final screen you can still again see the setup regarding resiliency that we are going to have. With the magic of the video editing, we will accelerate this process. All right, so let's go to our circuit and see what it looks like. Important is seeing that it's not provisioned yet, meaning that the provider side is not configured yet. So essentially we provided we configured the interfaces in the routers, but there's nothing attached to them yet. So this is the configuration we put: metered, standard, 50 meg. And if we go and have a look at the different peerings you can configure on top of the circuit, remember it's either private or Microsoft peering, there's nothing there. And there are some attributes like VLAN ID that you saw there, but we will have Megaport configure that for us. And for that, we need that service key you saw. So basically now when we give Megaport this service key, they are going to be able to locate the exact ports that we have deployed in the Frankfurt ExpressRoute location and configure the network to connect their router, so that Megaport cloud router that I showed you earlier, into our circuit. In order to do this, you give the key so that Megaport knows how to implement the connectivity. It shows you whether you want to configure the primary or the secondary link, because it's one key for both lines of the ExpressRoute circuit. We will do both. Let's start with the primary. This is essentially centric to Megaport's billing, where you can either have no minimum term and have a pay-as-you-go, or you can reserve some capacity and then have a discount on the final price. Then we configure this was the primary, and then we do exactly the same for the secondary. As you can see, the Megaport interface is very convenient, and especially if you are using or configuring a test of ExpressRoute for any reason, then this is great, because you don't have to deploy any physical infrastructure in data centers, but you can just use these Megaport cloud routers, and you can interconnect clouds as I'm doing here with Google, or you can use it as well, of course, for other clouds such as AWS and OCI. Okay, let's finish the configuration of the second line. All right, so what we just did is connecting the ExpressRoute routers, sometimes they are called MSEs, Microsoft Enterprise Edge, to the Megaport cloud router. So remember, the ExpressRoute routers, they have the autonomous system number in BGP of 12076, and we configure our MCR, our Megaport cloud router, with 65,000. As you can see here, after configuring those connections in Megaport, now the state is still non-provisioned, but when those lines are completely configured, this should transition to provisioned. So now the primary line is completely provisioned. So now we should be able to see that the circuit is provisioned from a provider perspective, and we can see as well that the BGP adjacencies are up. We can see as well the connectivity details, like the IP address, this VLAN ID 100. Not really important. It's something that Megaport picked, but let's remember that number, because now we can go to the Azure portal and see how that VLAN is used in the configuration. So essentially Megaport went to Azure and configured our ExpressRoute circuit accordingly. Now the state of the circuit is provisioned, as you can see. And if you go to the peerings, now there's the private peering, fully configured with the two subnets that Megaport chose for the transfer networks, for the transit networks between the ExpressRoute routers and the Megaport cloud router. We can have a look at the BGP neighbors The show IP BGP neighbors is called here a route table summary. It's a bit confusing, but this essentially shows you the neighbors. We are going to see here the Megaport cloud router with the ASN 65000. There you go. Each router in MSEs, in the MSEs, so remember we have two routers, will have the neighbor. So hence you can switch between the primary and the secondary and see the result of that command, show IP BGP neighbors in that case for both. We call them primary and secondary, but we do equal cost multipathing across them. By the way, if you were not able to see the BGP neighbor coming up, chances are that you might have a layer 2 problem, and this command allows you to inspect whether you're seeing the MAC address of the other side. So if you can, that means layer 2 is okay, and then you would proceed to do some of the troubleshooting at layer 3. In this case, Megaport did all of the work, so they did an excellent job. Then after the BGP, the MAC address are there, the BGP neighborship is there, you can inspect the routes, and you can see this 10.4.2.0, this is there, which is the Google subnet 10.4.2.0. So we can see that this route is now going all the way up to the MSEs. By the way, if you are a CLI person, you can as well inspect these tables, these routing tables, like the IP, BGP neighbors, as well as the routes, right? You can, here, for example, you show the ExpressRoute circuits that are provisioned in a given resource group. Let's, I like working with variables because then I can reuse the same commands over and over. As you can see, I have enabled the history autocomplete. So in this one, I'm doing the route table summary. Remember, this is the show IP BGP neighbor for those of you with experience with Cisco or Juniper. And this will show us that there's a single neighbor. In this case, we are doing it for the primary. You can as well replace in the command line primary for secondary. And then we can have a look at the routes at the show IP BGP table. So let's put there the variable name. These commands take a bit because they actually go to the physical router, run the command, and go back. So this is not showing configuration. This is showing the actual route table in the VRF of the Microsoft router. So you can see that route there. We can see the AS path with the Google autonomous system number, the 16, and then the MCR autonomous system number, the 65,000. We can also see that VLAN 100 that I was talking about earlier. We can see the /30 that Megaport configured on each of the two transit networks. So everything seems to be okay. Now, the next step would be connecting those two routers to the Azure environment. So far we are in the ExpressRoute location, but we want, of course, to connect to on-premises our workloads that we have in Azure. For that, we will create what is called in Azure an ExpressRoute connection. So you can do it from the gateway, you can do it from the circuit. In this case, we will go from the circuit. These connections are not only used for ExpressRoute, but also for VPN. Hence, they're in connection type. You have a couple of types. We will choose the ExpressRoute for the connection type. Here again, you see some resiliency suggestions. In this case, we are connecting our circuit to one single gateway. What this is telling us that we might want to consider to have a second circuit on a second ExpressRoute location, just in case that ExpressRoute location had an issue, but that's maybe something for another video. We will pick the circuit we want to connect with the gateway. We pick the gateway we want to connect. Here we select a weight that is ideally non-zero. This will make things easier on an eventual migration later on. And you go and create the connection. So what this is doing is creating a BGP connection between the router, the MSCE router, the 12076 router, with the ExpressRoute gateway deployed in the hub VNet. The ExpressRoute gateway, by the way, always has the 65515 outermost system number. Now, if we go to the gateway, there are some metrics you can monitor. It's interesting as well. You saw the recommended metrics for the circuit. It's interesting as well having a look at the metrics of the gateway as well, and potentially configuring some alerts to notify you if some of these metrics go in a place they shouldn't go. For example, one I like is the count of routes. You can do count of learned routes, of advertised routes. These are always interesting to follow. All right, so let's have a look at the virtual network gateway while the connection is provisioning. You can also inspect the gateway routes with the CLI, with the command line interface. In this case, the command I issued lists the existing gateways. You can see the name there. I assign the name to a variable, again, so that I can reuse my commands. And first I will start listing the potential options that you can use in these commands. You can see here useful commands such as the BGP neighbors or peer status and the learned and advertised routes. We can start with the BGP neighbors. And since the connection is not provisioned yet, we shouldn't see anything yet. Well, we do see the neighbors connecting. What I meant is they're not connected yet. They are in the connecting state, which means that the connection is not yet complete. We will verify that by inspecting the learned routes. As you can see, there's nothing learned over BGP. There's only these two routes that are the virtual networks that are existing in the environment. One is the hub, the first one, and the second one is the spoke. You could equate these to the connected routes in a router. When you have no routing protocol, the only routes it knows is the ones directly connected to it, in this case, the spoke and the hub VNet. If we go back to the portal, we see the connection is now completed. So let's reissue the commands. Now the BGP neighbors will show them as connected, and you can see as well the time over which they have been connected. If we inspect their learned routes, we will also see additional routes coming in from BGP, and most specifically the 10.4.2.0/24. And you can see in the AS path that is coming over the 12.076, which is ExpressRoute, the 65,000, which is Megaport, and then the 16.550, which is Google. The other routes are the transit networks between ExpressRoute and Megaport and Google. You can also have a look at the advertised routes. In this case, you have to specify one neighbor, so you will see the routes that are being advertised over BGP to that specific neighbor, and you can see that it's the two connected routes, the two VNet prefixes for the hub and for the spoke that are being sent over to ExpressRoute. You can see this as well if you inspect the neighbors and the route table, or actually the BGP table in the circuit, in the MSCEs. If we start with the routes, with the BGP routes, we will see now routes coming from the gateway, which again it's 65.515. That's how you can identify these routes, looking at the AS path. You can see here those two at the top, the 10.110, that's the spoke, and you can see the ones at the bottom, which are the hub, this 192.168. Interestingly, the key attribute to notice is the AS path, which is how you can identify that these routes are coming from an ExpressRoute gateway, because they are only for the 65.515. You can also verify the BGP neighbors with the route table summary option. And we will see here now the two ExpressRoute gateways showing as BGP neighbor on the 65.515. We have our 65,000, which remember was the Megaport cloud router, and now the two ExpressRoute gateways. It's one ExpressRoute gateway, but it's two instances for resiliency. Everything is set up. We can now go to our virtual machine. This virtual machine is in a spoke, and In order to verify that the virtual machine has the correct routing, we can inspect its effective routes. Essentially, the ExpressRoute gateway is going to inject the routes it learns over BGP into the virtual machine so that the virtual machine can reach the on-premises location. So here we should be seeing the 10.4.2, there it is, coming from a virtual network gateway. This is the route. It's in the effective routes, you can see where this route is coming from. You could see that it was coming from a virtual network gateway. The reason why the spoke virtual machine is learning the routes from the virtual network gateway in the hub is because how the virtual network peerings are configured. We can have a look at the peering from the spoke to the hub, and we will see that the setting to use the remote gateways is enabled. This is very important because this allows the spoke to send the traffic to the virtual network gateway. And in the opposite peering from the hub to the spoke, we can check that a similar feature has been activated, which is called allow gateway transit. This allows the gateway to receive that traffic from the spoke and forward it to on-premises. Okay, now we have verified that routing works, so the virtual machine should be able to reach on-premises. We can connect to the virtual machine via the remote serial console. In order to do that, first we need to enable boot diagnostics. Let's do that quickly with a managed storage account. And then we can connect to the virtual machine via the console. And what we will do is just a quick ping and a traceroute. For a traceroute, I will use MTR, which in my opinion is a much better traceroute because you can use TCP packets instead of ICMP, which tend to behave better. Okay, first let's log in into this virtual machine. And now we will ping the on-premises VM, which has the IP address 10.4.2.2. We will send 5 pings, and sure enough, it works. We'll do a traceroute with this MTR command that is sending TCP traffic on port 22. Again, very useful. If you didn't know it, I strongly recommend it. We see here something interesting. We don't see the VNet gateway as hub, but we do see the .170 and 174, which is the MSEs. And then we see the Megaport cloud router. It's only one, and it happened to pick the 169 as its address where it's answering the trace routes, the TTL expired in transit packets. So the one thing to consider here is that you won't see the virtual network gateway, the ExpressRoute gateway, in the trace routes. We can also inspect the network security rules. We are having here two NSGs, one applied in the NIC, one applied in the subnet, but both are identical and they have just the default rules. And the one at the top allows traffic between virtual network and virtual network. What is actually this virtual network? In the past, you were able to see that in the portal. However, this is not possible anymore. And you need to use the Azure CLI, PowerShell, or the REST API. What we are going to do here is to use the option for the Azure CLI to list the effective NSG rules, as you can see on the screen. We will output in JSON because we are not interested in the rules themselves, but in the bottom part of it, which informs how this virtual network security service tag is expanded into actual IP addresses. So as you can see here, this is the last part, the virtual network. We can scroll up and see the other service tags that are present here for the load balancer, for the internet service tag. That's actually also a service tag because this excludes any prefixes that are defined in the VNet. And we can see, interestingly enough, that the virtual network service tag contains maybe more than you would have expected. It contains, of course, the spoke VNet, because this is a virtual machine in the spoke, but it also contains the hub and even the route that is being learned over ExpressRoute, this 10.4.2. Okay, so this was all for today. I hope this video helped you to understand better the end-to-end provisioning process of ExpressRoute and which knobs and settings and troubleshooting tools you can resort to if you ever have any issue working with ExpressRoute networking. Thank you for watching and stay curious.